In this video, we are going to find answer to this question. A fair coin is repeatedly tossed until you get 3 heads, one after another, consecutively, H. And then you stop. What is the expected number of tosses that you need? So let us first mathematize the problem. I will define the random variable x3, which is the number of tosses up to and including the first occurrence of H. So basically x3 is exactly the number of tosses. So it is expected value of x3 that I am trying to find out. Now in order to solve the problem, I will need to define 2 similar other random variables. x2 is exactly the same thing except that I am using HH. So the number of tosses up to and including the first occurrence of 2 consecutive heads. Similarly, this is number of tosses up to and including the first head. So x1 you will immediately recognize as just a geometric random variable. I am interested only in x3, but these things will play an important role. Just to make sure that you understand the definition, let's take an example. Suppose our original sequence is like this. Our random experiment was I am repeatedly tossing until I get 3 consecutive heads and I have stopped. So here I have x1 coming here. So x1 will be equal to 2 up to and including the first head. x2 is 1, 2, 3, 4, 5. So I have x2 equal to 5 and x3 is equal to 6. Just an example. Now, since I know that x1 is just a geometric random variable with parameter half because the coin is fair, hence it has expectation reciprocal of half, that is 2. Now we shall try to find out this one and then we will attack our x3. Now think of x2 in the following way. Instead of trying to find out expected value of x2 in one go, I shall try to find out this conditional expectation. I give you the extra information that x1 is 3. Now tell me what is the expected value of x2. Now what is meant by expected that x1 is equal to 3? This means the first head occurred at toss number 3. Hence the tosses are like tail, then head. Now the first head came here. If the next head comes immediately, I will get x2 equal to 4. So given that x1 equal to 3, there is a chance that x2 can be 4. How much chance? The chance is half. So I will write it in this way. With probability half, this thing is going to be 4. So this 4 is actually 3 plus 1. So I will write it as 1 plus 3. I have already spent 3 and the very next one can be another head. But it is also possible that the next one happens to be a tail. But if it is a tail, then I have to start my search all over again. How long do I have to wait? Well, I do not know. So I will give it a name. I will call it Y. So expected value of x2 will be expected value of y. Y is the amount of time that you have to wait starting from this point, waiting again all over for HH. But all the tosses are independent. So if you are starting all over again, this expectation is exactly same as your original thing. So the quantity that you are trying to find out originally, expected value of x2, you will get back all over to that again. But there is a little bit of catch. The catch is you have already wasted 4 steps. Right? You have already wasted 4 steps. So it is this plus 1 plus 3. So you will again have the same expectation all over again, but this after wasting 4 steps. 3 for x1 and 1 for knowing that all your hope is shattered, and then you start all over again. So this is the crucial step. Try to understand how I got this. Now, in general, I will not give you x1 equal to 3. I can give you x1 equal to, say, 4. In that case, this will be 4, that will be 4. In general, I will have expected value of x2 given x1 is, here I will write x1 and here I will write x1. Understand once again? This means that I had up to x1, I already have one head. Then the very next one can be head with probability half, and then x2 will be just 1 over x1. Or this is tail with the remaining half probability, in which case I have already wasted 1 plus x1 many tosses and my search starts all over again. So I again have expected value of x2. And this expectation is unconditional because I am starting all over again. This is independent of whatever happened in the past. Now I shall apply tower property to this in order to get expected value of x2. Expected value of x2 is expectation of this conditional expectation. So I will just write it. Wherever I have find x1, I will replace it by its expectation, and hence I will get. Now if you simplify it, just combine, this occurs in multiple places. So you will have half plus half, that will give you 1. Half of expected value of x1, half of expected value of x1, that will give you one entire expected value of x1. So you will find this half goes away and you really do not need to have this. So you have only this. Now whatever I did to move from x1 to x2 can be used to move from x2 to x3. Again the same thing. If you got your first two heads, then the very next one can be head, probability half, in which case you get x3. Or your start starts all over again. So the exact same thing repeats. So I can also have expected value of x3 is 1 plus expected value of x2 plus this. Anyway, I already have expected value of x1. So you can just put it here and solve for expected value of x2. And let's see what I get. We have expected value of x2 equals 1 plus 2 plus half of expected value of x2. Take it on this side, you will get half of expected value of x2 is just equal to 3, from which you get expected value of x2 equals 6. Now as I said, we have a similar equation that will give you expected value of x3 in terms of expected value of x2. Expected value of x3 is 1 plus expected value of x2 plus half expected value of x3, just imitating this. Now you know expected value of x2 is 6, so just plug 6 in here. So it is 7. So half of expected value of x3 is 7, which means expected value of x3 will be equal to 14. And that should be the answer. And similarly, you can go on to x4, x5, etc. All these things are similar.